Welcome to Hardly. Each book is distilled into 3 stories, giving you the key ideas in minutes. Today, we study together Snow and Brownlee's The Sixth Element, How Carbon Shapes Our World, in which we probe into the discovery of carbon and its cosmic origins, the chemistry that makes carbon essential for life, carbon's impact on Earth's future, from life to climate change. Theodore P. Snow is Professor Emeritus at the Center for Astrophysics and Space Astronomy at the University of Colorado Boulder. Don Brownlee is Professor Emeritus of Astronomy at the University of Washington. Don't go away. Hardly, the editor, will be right back with the story. Today, we'll journey through 3 interconnected stories that illustrate carbon's incredible role in our world, its cosmic origins, the life-giving chemistry it fosters, and its impact on Earth's future. These tales will bring us from the heart of stars to the ground we stand on, and finally, to the challenges we face for a sustainable future. It all begins in the fiery heart of a star. Fred Hoyle, a rebellious astrophysicist, once stood in front of a room of skeptics and made a bold claim. Carbon was born in the stars through a process that defied the odds. Imagine the chaos. High-energy collisions, nuclei smashing into each other, and somehow, miraculously, carbon emerges. Hoyle's theory centered on the idea that a rare state of carbon, the Hoyle state, allowed this formation. Without it, none of us would exist. And Hoyle knew this. His persistence was key. As one excerpt from the book notes, Hoyle deduced that carbon must have a previously unknown excited state with an energy level that allows some of the carbon to linger until it reaches a stable state. Without this discovery, life as we know it wouldn't be possible. But Hoyle wasn't just after the scientific facts. He was reminding the world that the universe, against all odds, is aligned for life to exist. That's a humbling thought. The cosmic origin of carbon shows us the interconnectedness of the universe. The story of Hoyle's breakthrough sets the stage for our next tale. From stardust, carbon travels across galaxies, eventually making its way to Earth. Here, its role takes on a more intimate significance. On Earth, carbon isn't just an element, it's the backbone of life itself. In a cramped lab, French chemist Antoine Lavoisier is meticulously weighing and burning substances. Lavoisier was obsessed with understanding how matter worked, particularly carbon. His experiments with graphite and charcoal revealed that when these were burned, they produced a mysterious gas, carbon dioxide. Whenever they burned something in a sealed container, the total weight always remained constant, the book mentions, which led to Lavoisier's revolutionary realization. Matter was neither created nor destroyed. This was one of the building blocks of modern chemistry. Lavoisier's work gave us the framework to understand carbon's role in biological processes, explaining how this element could form complex molecules like proteins, carbohydrates, and fats, everything we are made of. Carbon's unique ability to bond with almost any other element gave rise to organic chemistry, the foundation of all life on Earth. His careful, methodical work shows us the importance of deep understanding and attention to detail, a lesson that stretches far beyond chemistry. Now, let's zoom out from the lab to the bigger picture, how carbon, the life giver, is also intricately tied to Earth's future. Fast forward to our current reality, the atmosphere. As carbon continues its journey through time, it now finds itself trapped in our air in the form of carbon dioxide, one of the major drivers of climate change. Today's story shifts to the delicate balance that this gas maintains. Scientists around the world are racing against time, trying to curb the dangerous levels of carbon dioxide in our atmosphere. One of the more poignant sections of the book discusses carbon taxation, a tool that governments have implemented to reduce emissions. Beginning with Finland in 1990, many countries now have some form of carbon tax as a way to stimulate migration to other forms of energy, the authors write. This story isn't just about carbon anymore, it's about humanity's collective struggle to mitigate the effects of carbon emissions. From fossil fuels to clean energy solutions, the carbon tax reflects a growing awareness that we can no longer afford to ignore carbon's dual role in both our progress and our destruction. As these stories unfold, there's a clear pattern. Carbon, in all its forms, constantly shapes the world around us. Whether forged in the heat of stars, bonding life together, or filling our skies with gases, carbon is always at the center of the action. What's more, these stories remind us that carbon doesn't just create life, it challenges it. From Hoyle's cosmic insights to Lavoisier's laboratory, and finally to our modern climate crisis, carbon demands our attention. The lesson from these stories is simple but powerful. Understanding carbon's past helps us navigate the future. In the end, carbon is both our ally and our adversary. So, what can we do with these lessons? Carbon teaches us that small changes, whether in scientific understanding or environmental policy, can have monumental effects. Just as Lavoisier's detailed experiments helped us grasp the building blocks of life, so too can our small shifts in energy consumption and environmental responsibility create waves of positive change. And if Hoyle's stubborn belief in the power of carbon formation led to scientific breakthrough, maybe our collective persistence can lead to a future where we coexist with, rather than battle, the forces of carbon in our atmosphere. As the editor of Hardly, I believe these stories show us that by understanding the intricate dance of carbon, from its cosmic birth to its earthly challenges, we can shape a future that honors our environment and sustains life in more profound ways. Each story comes from the most representative real-life cases selected by the Hardly team from this book. In fact, there are at least 10 more stories in this book, each offering unique insights into the role of carbon in shaping our world. If you wish to dive deeper, we recommend purchasing the full book. In this exploration of carbon's transformative journey, we revisited 3 critical points: its cosmic origins, its fundamental role in life on Earth, and its impact on our planet's future. But before we close, let me share one last story that left an unforgettable mark. In the early 2000s, astronomers discovered a white dwarf star named BPM 37093, better known as Lucy, because it's essentially a massive diamond floating in space. The star's core has crystallized into carbon under intense pressure and heat, forming a diamond with a mass equivalent to the Sun, but packed into a space the size of Earth. This discovery fascinated both scientists and the public, becoming a symbol of how carbon, an element so common to our lives, can take on new, unimaginable forms in the vastness of the universe. It shows that even at the end of a star's life, carbon continues to surprise us, reinforcing its presence in every corner of existence. This final story illustrates once again how carbon's unique properties shape not just life on Earth, but the cosmos itself. Whether it's forming diamonds in space or fueling the evolution of life, carbon's versatility reminds us of its unyielding influence. As we wrap up, remember that carbon isn't just an element. It's a storyteller, weaving its presence through every facet of our world and beyond. Through understanding these stories, we can better navigate our shared future with this extraordinary element.